children, today we are going to see when the object is rolling inclined plane. Okay, when the object is rolling at inclined plane, what is the final velocity of the object? Okay, I am going to take it three different object. One is a ring, another one is a cylinder, another one is a sphere, and also disc. You can, if you want, you can take it as a disc also. Okay, so three things we are going to take it. One is a ring, another one is a disc, another one is a sphere. The three example I am going to give. Okay, the object is rolling at an inclined plane. There are two types of energy we will get. We are going to find what is the final velocity for three different cases. Okay, so final velocity, before going to the final velocity, first we will see what are the energies is there. So total energy, total kinetic energy is going to be a it is two types of energy is there. One is a rotation, another one is a translation. Total kinetic energy is going to be a rotation plus kinetic energy of translation. The another thing, the object is rolling because of potential energy is stored in this particular object. Okay, when the object is at some height, so the potential energy stored on the object, we know potential energy is equal to mgh. So m is the mass, g is the gravity, h is the height of the object. So this is a potential energy is going to convert into two form of energy. One is a rotational energy, another one is a translation energy. So total potential energy is going to convert as a kinetic energy of rotation plus kinetic energy of translation. So as I already said, three different objects we are going to see. So first we will derive, then we will see what is the three different object. Okay, so potential energy mgh, kinetic energy for rotation motion of I omega square, for translation motion of mv square. So in rotation motion, mass we can take it inertia, velocity we can take it angular velocity. So for inertia, already I know it is a inertia is equal to it is a mass times of k square, radius of gyration. K is called radius of gyration, it is not a radius. Okay, so omega is equal to relation between v and omega. V is equal to omega times of r. So omega is equal to v divided by r, because already we know theta is equal to s divided by r. So s is equal to theta into r. When we are differentiating this equation, displacement by time, which is going to be linear velocity, angular displacement by time, which is going to be angular velocity. So omega is equal to v divided by r, inertia is equal to mk square. So just I am going to substitute, instead of I mk square, instead of omega I am going to substitute v divided by r. Just we are going to see what is going to happen. mgh is equal to of I know mk square, omega I know it is v divided by r, it's whole square, plus of mv square. So this is the equation, v square divided by r square. So of mk square v square divided by r square plus of mv square. I am taken off mv square is the common outside. So of mv square of mv square I am taken outside. So of v square I am taken outside. The inside will be v square divided by r square, v square divided by r square plus 1, because here all the term we are taken common outside. This side will be mgh, m get cancelled. So we are going to find what is the velocity. So this you can bring as a denominator. This directly you can bring as a denominator. So 2 you can take it as a numerator, cross multiplication. So v square is equal to 2 times of gh divided by it is k square divided by r square plus 1. So I got what is the final velocity. V is equal to root of 2gh divided by k square divided by r square plus 1. Okay, now I am going to do it with the special case. First thing we are going to take it as the disc, a ring. Okay, when the ring is moving as an inclined plane, so it will move this side. Okay, so when the ring is rotating at perpendicular to the ring, the inertia will be m r square. The r is the radius of gyration. Okay, so r is the radius of the disc also here. So already we wrote inertia is equal to mk square. It is for the ring, the inertia will be m r square. The same thing mk square we are taken, so k square is equal to r square. So k square is equal to r square for the ring. So when the ring is rotating as an inclined plane, so we'll get k square is equal to r square. So k square is the r square. So final velocity of the ring is equal to root of 2gh, k square is equal to r square. So I am going to write r square divided by r square plus 1. So r square get cancelled. So we'll get 2gh divided by 1 plus 1, which one we are going to get as a 2. So V is equal to root of 2gh divided by 2 to get cancelled, root of gh. So finally we got velocity of the ring. Next thing I am going to do with the disc. Okay, the same thing when the disc is rotating as an inclined plane. So disc inertia, I know when it is perpendicular to the disc axis of rotation, when it is perpendicular to the ring, inertia is equal to mr square divided by 2. So that means inertia is equal to mk square. So k square is equal to r square divided by 2. So radius of gyration this much. So just I am going to take it now, k is equal to this much. So V is equal to root of 2gh divided by k, I know it is r square divided by 2. K square is the r square divided by 2. R square divided by 2, already here one r square is there. So r square plus 1. R square get cancelled. So V is equal to root of 2gh divided by 1 divided by 2 plus 1. So we have to solve this solution. So 2 we can take it as a LCM. So V, velocity of the disc, is equal to it is root of 2gh divided by this LCM. You can take it 2 as a common, 1 plus 2 will be 3. So root of 2gh divided by 3 divided by 2. So this will come into the numerator, so 2 into 2 will get as a 4. So velocity of the disc is equal to root of 4gh divided by 3. So it is a final velocity of the disc when it is rolling at inclined plane. Okay, the same thing sphere. When the sphere is rotating at inclined plane, the solid sphere, I know the inertia, solid sphere inertia will be I is equal to, it is 2 times of mr square divided by 5. Same, which is equal to mk square. That means k square is equal to 2 times of r square divided by 5. Except mass, remaining you can take it as a k square. So k square is equal to 2r square divided by 5. So for the solid sphere, what is the velocity? I am going to substitute now. It is a k square is it is root of 2gh. K square is it is 2 times of r square divided by 5r square plus 1. R square get cancelled. Just I am going to do the LCM. Root of 2gh, it is 2 plus 5 divided by 2. It's going to be root of 2gh divided by 7 divided by 2. Denominator directly will go into the numerator. 2 into 2 will get us the this 5 only will be in denominator. This 5 is directly going into the numerator. So 5 into 2 will get 10. Root of 10gh divided by 7 we got as the final velocity of the sphere. Okay, the another thing I want to tell you, disc. Okay, so already we saw the disc. What is the final velocity for the disc? In case cylinder, it's rolling. Okay, solid cylinder. So solid cylinder, when it's rolling, disc and cylinder will be having the same thing, because disc inertia and cylinder inertia will be the same, mr square divided by 2. That is the reason this is valid for disc or cylinder. It's a solid cylinder. Okay, thank you for watching my video. If you like my channel, please subscribe. Thank you everyone.